Okay, don't give up on this last page. I know it looks a little bit more difficult when you're looking at the least squares linear regression approach. But let's see if we can make this go really quickly by going to the course home page and clicking on the homework link and downloading this table right here. So you want to right click, save target as, and I guess we can put this on the desktop, suppose. Let's see, there we go. And just save that to the desktop. And this is the table 8.5. So that is right there. That's the table. I've already typed it in for you. So all you have to do is go to the homework link to download that. Now, how is that going to make your life easier? Well, if you look at what you have to type into this or write down on your homework handout, well, these are the values right here, but doing this could be kind of tedious, and we know that Excel can do repetitive tasks fairly quickly. So to get this x sub I times y sub I, we've already determined that this is the x value and this is the y value on our graph. All you have to do is come over here and say equals, and then this times that. So we're doing voltage times current for the x times y. And of course, you know how we did this in project number 1. You just take this and then drag it down, and these are the values that you can just write in that column right here. You'll also need the x sub I squares. Remember that the x sub i's are the individual rows, so x1, x2, x3. That's really what those are corresponding to. And we need to square those. So let's come over here, and we're going to say this one is equal to, and then caret 2, like that. So we're squaring the voltage values, and those are the values that we can write in these cells. Now what we'll need to do this method of least squares linear regression are the summations of these columns. So let's go over here. I'll show you how to do that quickly. You can just say equals sum, sum like that, and then open parentheses, and then select the data you want to sum, close parentheses. So that's how you do a sum in Excel, and that can be the total value that you could probably just write in a row that you can make down here at the bottom of this table. You take this and you can either hit Control R, or I think you can just drag over like that, and you have the summations of the other columns. See if I can get this a little bit closer. So the n is the number of values that you have. So it's the number of rows, and of course you don't include the sum row when you're doing that count for the number of rows. And this is the sum of, well, it's that value right there. It's the sum of the products. This is the sum of the first column right there. This is the sum of that column. And this is the sum of the last one over here. Again, n is the number of rows, and be sure that you take, for this x sub I, you want to grab the sum right there and square it. The most common mistake there is to forget to square. You do the same kind of thing here for finding the y-intercept. So we're going to assume that we're not going through the origin for this method of least squares linear regression. On the back page. So we force it to go through the origin when we're doing it by hand, but when we're doing this with Excel, we're actually going to figure out what the y-intercept is. So here is the improved equation of the line. Again, we can start with that. Y is equal to mx plus b. We already said that our y value is going to be the current. The x value is going to be the voltage. This is going to be our slope, and we're going to put ampere over volts. So that's what we would get from up here. We'd take this slope value and we'd put that number right there. Okay, and also we would have this a y-intercept that we would put right here. Now the units on that, hopefully I can convince you that it would be amperes. Now the reason that should be is because if we're making a graph where the y value is current, and if we intersect that axis, it's going to intersect and have a y-intercept that also has units of amperes. Now on this last one it says use the hint provided in the problem. Now what am I talking about there? I'm asking you to go look at the problem in the textbook. Let's see if I can help you out with that. Well, once you find table 8.5, it's going to be oh well, this is problem number 1 in the back of the chapter. Okay, so what you find out is that if you plot I versus V, that the slope of that line is 1 over the resistance. So that's the hint in the problem. Not that hint. Well, this is the hint we're looking for right there. So whatever value that you get for the slope right here, you can use that to find the resistance. Simply take the reciprocal of it. Take the reciprocal of the slope and you've calculated the resistance. Now it says put the proper units on there, and hopefully it also tells us what the proper units are. Now if you take the reciprocal of, this units here, you get a volt over an amp. Now a volt over an amp, let's see if that's given in the hint. Yeah, here it is. Note, the unit of electrical resistance is an ohm. A volt over an amp. So make sure that you put a numerical value right here, measured in ohms.